remember these two functions? In the last video, we asked if you can express them using the ordered pair representation. Let's begin with a straight line graph, i.e. this linear function. We wrote this expression for this function in the previous video using the usual math notation, a formula-like expression. Now, in case we do not write down the domains and codomains, then it's always assumed that the domains would be the largest possible set. In this case, all the real numbers. Now, can we represent this function using the ordered pair representation? Well, if we attempt to write out all the possible pairs to represent the function, we will have an infinite number of pairs to write down, which is not at all practical. But you can write it down in this more compact form. So we have the object, the image based on the rule for all elements in the domain. I guess you can imagine how you write it down for this other function, where q of x is the square of x. The ordered pair representation can be written as follows. You have the object and the image in the pair for all x in the domain. Now, notwithstanding all this, the writing of functions using this formula-like expression has its benefits. It allows us to determine the image values very easily from the objects. Let's consider the example of the straight line graph again. Say you wish to determine the image for the number 2 of the domain. Now, you could in principle use the graph to do so. But it's not difficult to realize that you need a very accurately drawn graph. However, if you use this expression, where h of x is the image of the object plus 1, then the image for number 2 can be written as h of 2, which is equal to 2 plus 1, 3. What about the other function? What is the image for 2 for this function? Again, we consider this expression for the function. The image is equal to the square of the object. So the image of 2, q of 2, is equal to 2 squared, equals 4. Now we can try a more exotic problem. What is the image for the square root of 2? We just write out q of square root 2, which is equal to 2. Now effectively, this does look like we're just substituting x in the function expression with whatever object for which the image we are interested in, and then evaluate it. Well, you can think of it that way if you wish. Substitution. We'll be looking into more examples in the next video to help familiarize ourselves apart from other details.